Yeah, assalamu alaikum. Yeah, in electric field, yeah, we solved this question in class here, but the last question here, I I didn't read this correctly, so I just want to make a correction based on this last question. Okay, so you shall have to just watch the video and add to your knowledge. Yeah, whenever we're doing calculation on electric field, we have to go by the formula. E is equal to K, which is Coulomb's constant, over the R, which is the distance squared. So now the first question is the definition of electric field. The definitions, you have to refer to your books to know what is electric field and what is electric field at a point. Okay, so draw the resultant electric field pattern surrounding spheres P and Q. So we've also drawn the electric field pattern, and we said that once we have two charges which is same charges, they repel each other. So we have to show the charges moving away, repelling each other. Moving away. All right. Because they are all positive, we have to show the arrows moving away. You have to show the arrows moving away. Yeah. So to calculate the magnitude of the net electric field at point X, then we need to know that is 7.3. When we take our electric field at point P, now is equal to, we know our point in space, which is the point X. So when we consider the 2 point P and Q, we have our K, which is the Coulomb's constants, times 10 to the power of 9. And the Q is the charge, which is 5 times 10 to the power of negative 9. All over the distance, which is 0, which is 30 millimeters. 30 millimeters is the same as 0,03 squared. So this gives us 50,000 Newton per coulomb charge. So now when we consider the two, because they are all positive, the X will move to the right. So we know our direction is going to go to the right. So when we do the same thing, electric field at point Q, now is going to be the Coulomb constant, which is 9 times 10. 5 times, it is the same charge, 10 to negative 9. All right, over now, the distance is going to be 0,01, 0,01 squared. Because it is 10 millimeters, when we convert it to meters, it is going to be 0,01. So now this gives us 450,000. 450,000. But to what direction? It is still to the right, because the Q is positive, so they're still going to repel. So the X still goes to the right, so still to the right. So now our E net is therefore equal to, we're taking positive direction as going to the right as positive. So we're going to have 450,000 thousand plus 450,000. So which gives us the Q nets is going to be 500,000. That is the net electric field at this point here. Electric field at this point here, at this point X. So if we have at the point X, the net electric field at the point X, and now the 7.4 say hence calculate the magnitude of the electrostatic force that an electron will experience when placed at this point. The electron in the class, I thought they say when one of the charges is placed at that point, but it is mentioned here as electron. So if it is electron, electron has a charge of 1, comma. Yes, 1, comma 10, 1, comma 6 times 10 to the power of negative 19. Okay, it is electron, not one of the charge placed at that point. So if that is the case, then how do we calculate this? We have to say our E, which is the electric field, is equal to the force over the charge. Then what is the electric field? It is 50,000. So if I have my 50,000, okay, 50,000, sorry, 500,000. It's equal to the force, which I'm looking for, over the charge. What is the charge of electron? It is 1. Please don't put the negative sign in. Times 10. Whenever you are doing this calculation, ignore the negative sign. All right. So now, what is it going to be? Now, my F is therefore equal to that 500,000, which I can write it as how many zeros? 1, 2, 3, 4, 5. So to the power of 5 times 1, comma 6, 10 to the power of negative 19. So whatever I have from this is going to be my electrostatic force. So please, you have to bear in mind, please bear in mind, when they say the charge placed at point X, that charge is what you're going to use. If it is one of these charges placed at this point, then we are going to use this as we use in the class. I read it as one of these charges placed at this point, okay? But however, it is an electron placed at this point. So we have to use the charge on electron, which is 1, comma 6 times 10 to 19. That's it. So if there is anything you didn't understand, just message me so that I can make a short video and send it to you. Assalamu alaikum.